All right, this is the chapter 3 review. So starting off here, number 1, we've got this rectangular box. It's asking all these pairs of lines if they are skew, parallel, perpendicular, or intersecting. So let's take a look here at GH and BK. So GH is going along the bottom of the front here. BK is going along the back. So the first question is, are the lines on the same plane? The answer to that for these two lines would be no. The GH is on the front, it's also on the bottom. BK is on the back, and it's also on the right side, so those are not on the same plane. So then the next question is, are they going the same direction or different directions? They are going different directions, so that makes these skew. So different planes, different directions, they're never going to intersect, so those are skew lines. GC and AC, we don't even really need to look at the picture for this because they have the same letter in them, which means they are going to intersect at that point. So you don't even have to look at the picture. If you did, you would see that they do intersect right there. But if you have two lines that have the same letter in their name, then those are automatically intersecting. Furthermore, though, those would be perpendicular as well. Don't worry too much right now about the difference between intersecting and perpendicular. So those would be, oops, we'll go perpendicular. I'll just write the upside down T for perpendicular, because those would, even though it doesn't look like it, those would make a right angle at that corner there. Next, FH and CG. FH going up and down along the front, CG also going up and down along the front, so they are on the same plane, they're going the same direction, they're never going to intersect. That would make those parallel to each other. DF and GC. DF is going diagonally across the front. GC is going straight up and down across the front. So they are both on the same plane. They're both on the front, but they are not going different directions. I'm sorry, they are going different directions. So that means that eventually they are going to intersect. If you extended both of those lines, they would intersect somewhere. So those would be intersecting. They would not make a right angle, so they would just be intersecting, not perpendicular to each other. Next, EF and AB, EF going diagonally across this right side, AB going straight across the top on the back. Those are not going to intersect, so if we extended them, it would look like they would intersect if we drew it on the picture, but this one would kind of go off and above line AB. Line AB would just keep going horizontally that way, so EF would kind of, imagine three-dimensionally, you're going up, and this kind of just misses that line there. So those are going different directions. They're not on the same plane. So again, that means those are skew. ED and AB. ED going diagonally across the top. AB is that same line going straight across the back. And it is on the top as well. So those two are going to intersect because ED is going flat across the top, whereas EF was going diagonally across the side. So it would have risen up and missed the top. ED is flat across the top. So eventually AB and ED will meet off in space somewhere over here. So those again are intersecting. All right, next, number 2. According to the diagram's markings, is angle 2 congruent to angle 3? Well, we only have one set of parallel lines here. We have to be really careful. So we only have that line BC and line AD are parallel to each other. It looks as though AB and DC might be parallel to each other, but we don't know for sure. So based just on the fact that only AD and BC are parallel to each other, we could only say that these alternate interior angles, 5 and 7, are congruent to each other. We cannot say the same thing for angles 2 and 3 because those are alternate interior angles in between lines AB and DC, which we don't know are parallel. So we cannot say that. That would be no, because we don't know if AB is parallel to DC. If we did, then we could say that those were congruent because they're alternate interior angles with parallel lines, but we don't know if this line is parallel to this line, so we can't say that these alternate interior angles are congruent to each other or not. On part B though, for angle 5 and angle 7, we can say that. So as I just said, we do know that line AD and line BC are parallel to each other, so we can say that these alternate interior angles are congruent to each other. So this is yes, because AD is parallel to BC, and 5 and 7 are alternate interior angles. Again, since 2 and 3 are also alternate interior angles, but we don't know if those lines that are making up angles 2 and 3 are parallel to each other. We do know that the lines making up angles 5 and 7 are parallel to each other, so we can say that those alternate interior angles are congruent. All right, next, number 3, state a valid conclusion based on the given information. Sketch a picture if you're having trouble. That's strongly recommended. So we've got A is perpendicular to F. So we'll draw it like this, AF. And G is also perpendicular to F. So G would have to go like that. So if we know those two things, we could conclude that A and G are parallel to each other. Okay, so we want to make a conclusion, either a third pair is perpendicular or parallel or something like that. So we're given two pieces of information, we want to make a third conclusion. Next, we've got H parallel to K. Okay, and then H also parallel to W. Well, if H is parallel to K and W, then K and W are also, parallel to each other. So our conclusion would be that K is also parallel to W. Next, P parallel to Q. And then R perpendicular to P. Well, if P is parallel to Q and R is perpendicular to P, then R is also perpendicular to Q. So that would be our conclusion there. All right, number 4, given that angle 1 is congruent to angle 3 and that angle 1 is supplementary to angle 2. So we'll go like this. Okay, so first thing we want to notice is that 1 and 3 are same side interior angles. 1 and 2 are also same side interior angles, but dealing with a different set of lines. So 1 and 3 are same side interior angles with lines H and K. 2 and 1 are same side interior angles with lines V and W. Okay, so it's asking two questions. Is V parallel to W and is H parallel to K? Well, 1 and 2 and 1 and 3 are separately both same side interior angles. However, if we have parallel lines, the same side interior angles should be supplementary to each other, not congruent to each other. It's possible that we could have, congruent same side interior angles. Let's say this angle was congruent to this angle, but these lines are not parallel to each other. Okay, so it's possible that same side interior angles are congruent to each other, but that the lines are not parallel. It is possible that they're congruent to each other and they're both 90 degrees, which would make H parallel to K, but we don't know that they're 90 degrees. All we know is that they're congruent to each other. They might both be 80 degrees. They might both be 89 degrees, something really close to 90, but not quite 90. Okay, so 1 and 3 are congruent. We need them to be supplementary in order to make line H parallel to line K. So since they are not supplementary, they are congruent, this answer would be no, because your same side interior angles are congruent, not supplementary. However, when we look here, 1 and 2 are same side interior angles in between V and W, which means that since they are supplementary to each other and they're same side interior, that would make V parallel to W. So this would be yes, because same side interior angles are supplementary, which is one of the ways we can prove that lines are parallel. All right, state the slope of the line. So slope y2 minus y1 over x2 minus x1. So here we go. y2 minus y1, 14 minus 6. x2 minus x1, 3 minus 4. 14 minus 6 is 8. 3 minus 4 is negative 1. Always reduce. So 8 over negative 1 becomes negative 8. Same thing here. y2 minus y1 over x2 minus x1. Remember, we're subtracting a negative. That really means we're adding. So this becomes 9 minus 4, 5. 2 plus 7, 9. Both positive. So that doesn't reduce. We would just leave it as 5 over 9. All right, line K passes through the following points. Find the slope of a line that is parallel to line K. So parallel means they're going to have the exact same slope. So all we're going to do is just find this slope. Same thing we just did. Negative 6 minus 2, y2 minus y1 over x2 minus x1. So we've got negative 8 over 3. Okay, so that would be our parallel slope. And then perpendicular slope, remember, you're just going to take the opposite reciprocal. So opposite means opposite sign. So we're going to make it positive, and then we're going to flip the fraction. We're going to turn it into 3/8. Number 7, write the equation of the following that satisfies the following conditions. So we've got, let's see here, slope -5 passes through the point -3, 2. So we've got y equals mx plus b. Plug in what you know. You know this is x, this is y, this is m. Okay, so plug in everything you know. You know y is 2, m is -5, x is -3, and then we just need to solve for b. Okay, so multiply these together, positive 15, subtract 15, you get -13 for b. Okay, so go back up here, y equals, put in your slope, -5x plus your b value that we just found, or it's negative, so we could just write -13. So y equals -5 minus 13. All right, and then passes through the point 3, -6, and -2, 1. So first we have to find the slope. Okay, 1 minus -6 over -2 minus 3. 1 minus -6 is 7. -2 minus 3 is -5. We'd write that as -7/5. This just says write the equation, so we don't technically have to write y equals mx plus b. Y equals mx plus b is usually easier, but if we've got a slope like this, it might be a little bit easier to just put it in point slope form. So we can pick either of these points. It doesn't matter. I'm just going to pick this one. So my y coordinate would be -6. So point slope form, remember, is y minus y1, or in this case, it would be +6, and then equals your slope, -7/5, times x minus your x coordinate, which is 3. Just make sure whichever point you pick that you're using the same point. You can't switch between the 2 points for the x coordinate and the y coordinate. So you could have also, instead of the 6 plus 6, you could have put a -1 there if you use this point, and then instead of -3, if you used the 1 here, then instead of -3 here, you would have put +2 here for minus and -2. That would work too. So if we want to write that out, it could have also looked like this. This would have been acceptable as well. All right, see the next video for the rest of the review guide.